Okay, in this section, which is 11.3, we're going to talk about inscribed angles. And an inscribed angle is an angle whose vertex is on the edge of a circle. Okay? So this angle right here, angle ACB, is an inscribed angle because its vertex is on the edge of the circle. Now every inscribed angle has an arc that it contains. This is called the intercepted arc. Now these two have a relationship, okay? An inscribed angle is half the measure of its intercepted arc. So in this case, angle B here is half the measure of this arc, okay? Now what we have to remember is, all right, the central angle, okay? The central angle, which is an angle whose vertex is in the center, the central angle's measurement, so let's say this was 50. The arc that goes with a central angle is the same. Those are both 50. All right, so if we go back to this concept, an intercepted arc is half of that measure. Okay, so if this is 50 out here, this arc is 50 degrees, and this angle would be half of that, which is 25. That's kind of how this concept works. So in this instance here, we have an example. We're trying to find the measure of this arc here. This arc is arc PT, and then we're also going to find the measure of this angle, angle PRS. Okay? So let's think about this. Okay? This arc right here, arc PT, okay? This arc goes with an inscribed angle who we can follow these lines here and we can see that angle PQT, that measure is 60. Okay, so this angle PQT goes with this arc. Okay, so I know angle PQT is half of the arc PT as stated above. All right, so if this angle is 60, all right, I know that's half of the measure of that arc. All right, so this arc right here, arc PT, should be double 60, which is 120. Okay? And let me get rid of that. And let's talk about this angle right here, angle PRS. Angle PRS is equal to half of its intercepted arc, which would be this arc all the way to here. All right, that's arc PTS. Okay? So if I can figure out the measure of that arc, I could just take half of it and I'll have the measure of that inscribed angle. Now, arc PT is 120 and arc TS is 30. So I know the entire arc would be 120 plus 30, which is 150. Okay? So I know it's half of 150 then. So this angle down here is half of 150, which is 75 degrees. Okay, here's another example. We're going to find the value of y and x. Okay? And this is, again, the concept that an inscribed angle is half of its intercepted arc. All right, so let's start with angle x here. This one labeled x, which is angle DGF. Now, this angle starts here and goes all the way around to here. So the arc I'm using here would be this arc DEF. All right, so I know that angle G down there is equal to half the measure of arc DEF. All right, so angle G, which is my x, is 1/2. It looks like it's 80 plus 70, so that's 150 again. All right, we know half of 150 is 75. All right, so this is 75. Okay? All right, now, this angle down here, angle D, we'll call it. Angle D is half of, let's see, starts at E, and we're going to end on G. That's where the angle opens up to. So the intercepted arc would be all the way around to there. So that's arc EFG. So if I can figure out that arc, I can figure out the angle. Okay, so this part's 70. Now, I don't know what that part is, so I'm going to figure that out. Now, I know all the way around in a circle is 360. So I can figure this part out because we're missing, that's the only piece of this circle we're missing. So this arc is going to be 360, and we're going to subtract the rest of these, okay? So I can get that part. Once I get this part, arc FG, I can add it to 70, and then I can cut it in half and find my inscribed angle. All right, so we're going to go 80 plus 70 plus 90, and we're going to subtract that from 360. Okay, if we add those numbers up, we get 240. And if we subtract 360 and 240, all right, we get the measure of this arc, which is 120. All right, so again, from here all the way to here is going to be the measure of the arc I need, which is 70 plus 120, which is 190. So I know the measure of this angle right here is half of 190. All right, do that right, you get 95. All right. Okay, a couple of other concepts for inscribed angles. These are corollaries to the inscribed angle theorem, again, which was the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so here's three more concepts that follow that. All right, two inscribed angles that intercept the same arc are congruent. All right, so let's take a look at a little diagram here. All right, let me draw a circle for you. All right, so if I have an inscribed angle, let's say I have this inscribed angle. Okay, so this inscribed angle intercepts this arc right here. If I have another angle, another inscribed angle that intercepts that same arc, okay, then these two angles are going to be congruent. All right. The second one says an angle inscribed in a semicircle is a right angle. Okay, and let's take a look and see how that works. So let's do a little diagram here. All right. So if I had a semicircle, right? So if I had an angle that intercepted a half circle, so let's say I had this angle like this. There's our inscribed angle right here, all right? Now a semicircle is 180, so that means an inscribed angle that intercepts 180 would obviously be 90. All right, and then last one here says the opposite angles of a quadrilateral inscribed in a circle are supplementary. All right, so let's talk about how that works. So again, we have a circle, and inside the circle we're gonna draw a four-sided figure. All right. Okay, so what this is saying is the two opposite angles, okay, so angles 1 and 2, angle 1 plus angle 2 are supplementary, which means they add up to 180. And then the ones that are across from each other here, angles 3 and 4, also add up to 180. All right, so let's put those to use here. Using the corollaries, and we're going to find these angle measures. Okay, so example A, find the measure of the numbered angle. So here's our angle right here. Now this angle comes out to this part and out to this point, so it intercepts a half circle, which is 180. Okay, so I know angle 1 is half of 180. These two are there just to kind of steer you away from that. All right, so there's that one. That one's easy. All right, and that was the second corollary up here. Okay, the second one here, example B, we're trying to find this angle. Okay, this angle right here. Now this angle comes out and intercepts this arc right here. All right, now this arc is also intercepted by this inscribed angle. All right, so if you look at corollary 1, all right, it says two inscribed angles that intercept the same arc are congruent. So that means angle 2 is also 38 degrees. Again, this 70 is there to steer you in the wrong direction. Okay, here's another example. All right, we're looking for the value of B, and we'll do A as well, and A. Okay, so let's start with A first. All right, that angle that's labeled A, okay, it intercepts this arc, and that arc is a semicircle, a half circle, so I know angle A is half of 180, which is a right angle. That's pretty easy, okay? All right, now this arc right here we're trying to find, okay? And what we're going to do is this arc right here, this arc, it is intercepted by this angle. So if I know this angle, I can get that arc. So this angle right here, I'm going to use the triangle here, and I know all triangles add up to 180, so we're going to go 180 minus, and we're going to add up 90 and 32 and subtract that from 180. So if we do that correctly, you get 58 degrees. Okay, 90 plus 32 was 122. All right, so this angle right here is 58. Now, this angle 58 was half of that arc, so I'm going to go 58 times 2, and that should give me that arc, which is 116. Easy enough. Okay, last, but certainly not least here, we're going to talk about an angle formed by a tangent, okay, which is, again, a tangent line is a line that hits the circle at one point, okay, and a chord. All right, so here we have a tangent and a chord. All right, when you have a tangent and a chord that make up an intercepted or an inscribed angle, it's the same concept. It still has an intercepted arc, and it's still half the measure of that arc, okay? So let's say this arc in red right here was, let's say it was 120 degrees. That means this angle would be half of that, which is 60. And the same goes over here, okay? This angle right here is half of that arc, okay? So let's say that arc was 300 degrees, and that means this angle would be half of that, which was 150, okay? That's how this works. So we're going to use that to figure out example 3. In the diagram on the right, KJ is tangent to the circle. All right, so there's the point of tangency, okay? And we're going to find the values of x and y, all right? So let's start with this angle right here. This angle x is created by the tangent and the chord JL. So if I know that arc, I can get that angle, all right? So how do I get that arc? Well, this arc is also intercepted by this inscribed angle, okay? So how do I go from an inscribed angle to an intercepted arc? We're going to double it, okay? So this would be 70 degrees, which means this angle is back to half of that, 35 degrees. All right, now this angle here, this angle labeled y, is part of a triangle. All right, this angle up here, this angle intercepts a half circle again, so that's 90 degrees. So I'm going to subtract 90 and 35, that's 125, and do that right, I believe we get 55 degrees for angle Y. All right, let's do it. One more example with that. RS and TU are diameters of circle A. RB is tangent to circle A at point R. We're going to find the measure of angle BRT. So we want this angle right there. Okay, so we got to think about what arc is going to give us that angle. This arc right here, arc RT, is what we're looking for. Okay, if we can find that arc, then I can cut it in half and get that angle. Okay, so how do I get that arc? Now this arc is related to this angle. Okay, now that angle is a central angle. Okay, so let's refresh our memories here. Whoops. A central angle is congruent to its arc, whereas an inscribed angle is half of its arc. So it's important to know the difference between those two types of angles. Okay, so how do I get that angle? Well, I know this angle is 126. This angle and the angle I'm looking for, that central angle, those are supplementary. So this central angle I'm looking for is simply 180 minus 126. And if we calculate that out, this angle here is 54 degrees. Okay, so that angle is 54, which means this arc is 54, because Again, central angles equal or are congruent to the arc. So now this angle I'm looking for is simply half of 54. So if I cut that in half, we get that angle we're looking for, which is 27 degrees. Okay, here's another example. All right, we're going to find the value of each variable, and let's finish off notes here, this lesson. First, let's find the measure of this arc right here, arc A. Now this arc is going to be related to this angle. Now that angle is 25, so this arc is going to be double 25, which is 50 degrees. Okay? Angle B. Angle B intercepts a half circle, which is 180. So I know angle B is a right angle. That one's easy. And last, we have this measure here. All right? Angle C. All right, this one labeled C. C also inscribes and intersects a half circle, so this is also 90 degrees. And that concludes the notes on inscribed angles and their intercepted arcs.